Folks, we'll have a good break. This is kind of a nice little situation. In the past, it's been that come back to Thanksgiving, there's still like 2 weeks of classes and another week for finals. We just had this week, which is a little bit of a rush, but we'll make the most of it. So we're gonna start presentations in just a second. As a reminder, for all the presentations, assuming that you are not taking the final exam, you still have a responsibility with respect to these presentations. You do have to prepare group summaries. I give some guidelines on my expectations for the presentation summaries in the syllabus, but it's pretty straightforward. It's just a few sentences, bullet points, paragraphs, whatever you want to do about what the presentation is over. Once you've completed the summaries, then you will go to assignments on Brightspace. And you'll notice there's a nice little assignments folder for group presentation summaries. This is not a graded item, but it is required if you are planning on opting out of the final exam, which most of you in this class, I assume, are planning on doing. So please make sure you take care of that. Those of you who are taking the final exam, you will still want to take diligent notes, as there will be, I believe, 5 or 6 questions. I haven't decided which on the final exam over these presentations. So regardless of whether you're sitting for the final exam or not, take notes. That's all there is to it. If you miss something out or miss something and you want to review it, I will be posting these to YouTube as normal videos. For those of you who are a little bit antsy about having your presentations or your faces on YouTube, these will just be available for the next few weeks so people can prepare for the exams for them. At the end of next week, I will unlist them, so they will no longer be available. So I will protect your privacy, but it will have to be available for some people to access. That being said, we have 2 presentations today. So who wants to go first, LLMs or data breaches? LLMs it is. All right. Yes, yes. Okay, so you're first.
Right. All right, so we're going to talk to you guys about large language models today. We're just going to start with an overview. So what is an LLM? To know what that is, you got to know what a neural network is. So a basic definition of a neural network is that it is a computer system that's designed to recognize patterns. So how this relates to LLMs is that LLMs are a specific type of neural network that is designed to perform tasks that involve language. They're often referred to as next word prediction engines. Basically, it gets this name because of the fact that whenever you input language into the model, its goal is to provide a response by predicting whatever the next word is based off the data set that it has. So for example, with ChatGPT, whenever you put in a response, it uses its data set, which with ChatGPT is all the internet sources that it has and its previous experience to provide the answer that it thinks is the most likely. Another example is something like BERT, which powers Google's search engine. So something like that this can do is like whenever you're typing into the search engine, it has an autofill feature that predicts the next most likely word. And then some type of tasks it can perform. It can do things like image generation. It can translate text. It can do summarization, just stuff like that. And then getting into a brief history, the world's first chatbot was made in 1960 by a researcher at MIT. It was called ELIZA. And this was a very simple chatbot, but it still provided the foundation going forward for the other transformer models or for the other LLMs just going forward. And then in 2017 is when things really started to revolutionize with transformer models bursting onto the scene. This was a big deal because of the fact that they allowed much larger amounts of information to be used than had ever been able to use previously before. And then going forward, researchers' focus shifted more to like trying to provide more and more data into these models. And then in 2020, there was the release of GPT-3, which was important because of the fact that it had 175 billion parameters, which for context, GPT-2 only had like 1.5 billion parameters. So it was a really big step up from the previous one. And you can think of parameters as like variables that it uses to make decisions. So with more parameters, there's more data points. The answers are more likely to be accurate. And the jump to 175 billion just allowed for higher capacity and better performance. And then in 2022, ChatGPT was released to the general public, which was just a big deal because of the fact that this is when it really became mainstream. Tens of millions of people started using it pretty much right away, and basically everybody knows what ChatGPT is at this point.
All right, so next I'll be going over some of the main components of LLMs, how they work at a more technical level. So there are three main steps. The first one is tokenization. In this step, the model looks at words, and especially complex words, and will break them down into smaller chunks. So unhappiness would be broken into two chunks. Smaller words will just stay what they are for their tokens. So tokens and words are kind of interchangeable concepts, except they're just broken down into smaller components. So once those tokens are determined, we are going to assign numeric values representing the semantic meaning of each word. So this embedding map is a conceptual way to understand what the model is doing. So in this, the vectors are just long strings of numbers, could be hundreds of character or hundreds of numbers long, which determines the semantic meaning. So in this example, just on a 2D plane, we have dog and cat, which are represented very close to each other. This means that their numbers are going to be very close to each other. Worm would be a little bit further away, still an animal, but not as closely related. Book would be on the whole other side. It's unrelated in terms of its context. So this is what the embedding map and the vectors initially do. The third stage is called transformers. As Alex already mentioned, GPT in ChatGPT stands for Generative Pre-trained Transformers. So this is what the transformers do. Transformers have two phases. The first one is attention blocks. In this phase, we're going to look at each of the tokens that we have assigned vectors to and look at them in context with one another, determining which ones are the most important, which ones are most related to each other. So if I was saying, my name is Jack, the model is going to look at name and Jack as two highly related words, and they are the most important, given the most attention in this context. The vector values also will change in this step based on how the words are used in context. So book and worm, as I mentioned on the previous slide, very unrelated to each other. But when they're together, bookworm, it takes on a whole new meaning. This vector would then change and probably be combined into a single token to represent this different meaning. Multi-head attention is just looking at the word from different perspectives so that the model can provide a better response. The final step of this process is multi-layer perceptron, or MLP. Instead of looking at each of the words in context like we did in the attention block phase, we're now going to look at each word individually and run it through a neural network, as Alex has already talked about. In this step, we're going to be asking questions of each word, zooming out and looking at a big picture, what the purpose of each word is in the model. So at this point, we get an output, and this output is going to be represented by probabilities of the most likely next word. So whichever word is most likely to be chosen will be put into the response. And that's why ChatGPT will put out words one at a time, just kind of in a long sequence. It goes really quickly, this whole process, but that new word that is outputted is put back into this process so that it starts all over again with the new output information that it given.
All right, so now that we understand what LLMs are, we're going to take a look at what they are used for in accounting. So a lot of time is spent from partners and staff looking at tax law changes, keeping up with those. LLMs can help look at those and return those in a more simplistic way so that they're easier to understand. Financial reporting, some LLMs already have the ability to look at financial reports and return personalized recommendations and answer questions from clients on their financial reports, and even do predictive analysis to see where they might go in the future. And overall, the hope is that LLMs will reduce human error. One firm has even talked about the potential of a human-free tax return coming up in the future, although there's a big concern with data privacy and people accessing that in the future. Client interaction, so a lot of time obviously is spent invoicing with invoices, answering and asking questions, sending out emails. So if LLMs are able to pull the data from these large cloud data sets, they're able to, speed up that process, create a template, or even write out an email. I mean, I've used ChatGPT to write emails to people before as well. So just simple things like that, so that it just reduces the day-to-day functions of an accountant, so that they're able to focus on the more technical parts that LLMs are limited in. Big Four has already kind of developed their own use of LLMs. The most one that's like ChatGPT is PwC's AI tech, it's the same interface, so it's very simple, very straightforward. You just ask it a question and it'll return either an answer or it can write you a draft. Some of the more complex ones like Deloitte's Omnia, DNAV, and KPMG Clara are more like predictive analysis. So they look at data sets and like help audit documentation and auditors with their job. And then EYQ is also kind of like a ChatGPT based model, although EY has noted that it will become more advanced in the future. They recently just poured a couple $1 million into developing this technology. Yeah.
Now we're going to talk about the biases and limitations. So with biases first, you have the training data bias. That's just basically the data that is being used for training. If it's biased, it can cause skewed results and it would be misrepresenting what is actually happening. The algorithmic bias is basically a broader version of the training data bias. You can think of training data bias as like a subset. So even if the training data was completely balanced, the algorithm could still produce biased results because of existing stereotypes that are in our society. And then interaction bias, you can kind of manipulate like ChatGPT. Like one example is like depreciation in land. It'll say, hey, land is depreciable. And you're like, wait a minute, no, it's not. That's wrong. And it'll be like, yes, you're right. It just changes really easily. And if that's something simple, but if someone had malicious or harmful intent, that could cause for misinformation, and that would just cause a whole bunch of problems. So then limitations to knowledge scope, AI doesn't know everything. And when that happens, it will cause misinformation, or it will confidently say something when the answer is wrong. So you have to understand that not everything it's saying is correct. Next is reasoning and logic. I have this bolded because this goes with reasoning and logic. So I've made a claim: if all students in a school have access to a textbook, then they will all excel academically. And I asked this question, and then I got this result. And basically it said that if you have the textbook, you will excel in this class. So let me ask this a question. Raise your hand if this is true. If you just had the book for this class, how many of you would say you would excel in this class? Not a single hand, right? Because there's other factors like your motivation, the teaching method, how you learn. It's not just the textbook that is being used for this class for understanding. There are other factors, and that's what AI isn't getting. And then ethical and safety concerns. This is kind of, again, misinformation, privacy risk. If something goes wrong, then everything just is in cahoots. And then technical constraints. I'll be very brief because Andrew will talk about it a little more. But really, if you give ChatGPT a prompt and then you change it and you ask it something else, and then you want to go back to that previous prompt, it just has trouble remembering. It's not like the human mind where it can go back to that conversation. And then strategies to address these biases and limitations: regular audits, just making sure that the data you're being used is not causing skewed results, or it's not causing like a poisoning attack. Bias mitigation is really just making sure you're not constantly feeding the AI biased data. It is really impossible to completely remove bias, which is why you need to have the regular audits to make sure that it's not going to be skewed too much. Improve transparency and sources. That could be more for the knowledge scope, because then if it's able to prove sources for its answers, it's less likely that the information is incorrect. It's not confidently saying something without it actually proving it. And then educate users on the limitations. you guys have to understand that AI can't do everything. There's going to be things that they can't do and that those limitations need to be known.
Yeah, so the future of LLMs. So first we have multimodal capabilities. So what does multimodal mean? It's a model of AI that can process different types of data other than just text. So this includes video, picture, and audio, or video, picture, and yeah, audio. So some uses of this would be medical field. Let's say you go in, you get an X-ray, they submit the picture into a multimodal AI and ask, is there a fracture in this picture? If so, what bone is it on, and how can we treat it? So kind of to expedite that process. Another example is with autonomous driving. We already see this with Tesla, but it is going to get better as time goes on. It can show you different objects, vehicles, pedestrians, and read street signs, along with kind of defer against the different threats. So let's say you're going through an intersection and a car runs a red light. The AI could see this car coming and decide what to do to kind of protect its own passengers. With continual learning, this is what Jacob kind of hinted at. So continual learning is the process of learning and adapting to new tasks as they come on. But a big problem with this is catastrophic forgetting. And so let's say you have ChatGPT perform one task and it does it, and then you ask it to perform a second task. And by doing that second task, odds are it'll forget how to perform that first task. Now, this is getting better over time, but it's something that they really need to work on. And some things they want to accomplish with this first is task similarity. This is what Jack was talking about with the vectors. So it's regarding related and similar tasks. So a real life example would be, let's say you ask a tennis player to go play a game of pickleball. Odds are he's going to be good at both of them because he already plays tennis. So be kind of the same thing, asking them to do similar objectives. Next is task agnostic, and this is dealing with unknown variables. So let's say you build a model that you want it to identify different car models and car brands. It should be able to do that, but it should also be able to differentiate that a plane is different than a car, even though they both have windows, seats, wheels, things like that. Bias mitigation. So how LLM bias happens is it stems from the data that it was used to train from. And so it can be fed different stereotypes, like a nurse is a female or a CEO is a male, and it can follow that for its entire lifetime. A way to combat this, though, is through prompt engineering. And this would be you ask it to answer a question as if it were an expert in the field or part of a specific social group. And then by doing so, it'll reveal its own biases to you. And then the programmers can go in and solve these biases one by one. Lastly is human-like understanding. So a big problem with LLMs is they do not understand humans. They don't understand logic. They can't infer things. So a big thing with this is inferentialism, which is a theory to explain meaning by examining the roles of terms in a sentence and comparing them to each other. So an example I have here is the Treaty of Versailles. You could ask a large language model, when was the Treaty of Versailles signed? And it might respond with, oh, the Treaty of Versailles was signed in 1945 between Germany and France, which if you don't know, that sounds accurate because it'll say it very confidently. What it should do is focus in on on these words of Treaty of Versailles and realize, all right, that was signed to end World War I, so it should take place between World War I and World War II, and then kind of fix itself by doing that. Some uses for this would be therapy. So once we get conversational bots that understand human interactions, we can use them as therapy bots. So if people aren't comfortable talking to actual people, they can go talk to a bot to discuss problems. Next is social isolation. A big problem for the elderly is that they lack social interaction. So if you get conversational bots, kind of like the Optimus Tesla bot there, they can have conversations with the elderly, also provide reminders for, hey, you need to take a medicine or you need to eat dinner, things like that, and then encourage outdoor activities to keep them nice and healthy. Any questions?
All right, so should our goal for LLMs be to eliminate bias, or should it be to direct bias?
It should be the direct bias because you can't, like, bias is so hard to completely eliminate because every human has a different perspective. But if it's kind of like what Andrew said, the nurse being a woman, the CEO being a man, if you can make it so that it's more general than just like feeding it the same thing, then it won't continue to provide answers or responses that are following the bias that's in their training data.
So one of the points you made, you talked about depreciation of land, and there's an anecdote about a young man. I'm not going to say his real name. We'll call him Kyle. And actually worked with an LLM and said, I want to know the journal entry to depreciate or the tax treatment for depreciating land, and the LLM said land is not depreciable, and his response was, but I really want to. And then said, oh, in that case, and then actually came up with fictitious information about how to depreciate land and the tax treatment for that. The whole part of that anecdote, partially to make fun of Kyle, but also it seems to me that there seems to be a need for LLMs to provide information, even if that information is erroneous. Why do you think that is?
Well, I think using it in accounting, I guess, as accountants, we don't know everything and we don't know the constant, law changes, and, we probably have more specialized areas too as well. But like, if I have a special case where I don't know how to depreciate something and I need to ask, it's not like I really want to go look up a textbook or a tax code. I can just ask it in a more efficient manner. Like, how do I treat this depreciation? But then the accountant should also have that knowledge to know, oh, this doesn't seem right, or this doesn't quite match what I've learned before.
Do you think that the next evolution of GPTs would have GPTs that could actually say the words, I don't know? I mean,
I think it needs to be. It might not be something that they want to say, because it's supposed to provide something to help you. And if you're saying, I don't know, it's not really helping you. So I think it should be necessary, because then it's not spreading that misinformation. It's not confidently saying you can depreciate land. It's saying it could be something more of, I know that land isn't depreciable and this are depreciable, but I don't know the next steps to that.
other questions? Floor?
So good morning, everybody. My name's Madison.
So my name's Anna.
I'm Kennedy.
I'm Hannah.
And our topic today is on data breaches. So for our presentation, we're going to start with some background of the topic, then move to current conditions, as well as some examples of breaches. Then we're going to discuss the mitigation measures and then wrap up with some future considerations of the topic. So starting with the background, a data breach itself is an instance in which confidential information has been abused by an unauthorized party or an individual. And this information is often sensitive, private, and protected in some aspect, and the information has been abused in which it has been stolen, distributed, or viewed or accessed at all in general. So there are three main causations of breaches. So the first is innocent mistakes, and these are just accidental actions of employees within their role in the workplace where they're mishandling information that is confidential, either with internal or external parties of the company. These employees can also fall victim to phishing attempts or other social engineering attacks that can lead to the harm of the company. The second category is malicious insiders. These are employees that are abusing their authorized or their unauthorized access within the company to either have some personal gain, to get revenge of some sort, or to just harm the company as a whole. And the last method is hackers. These are external attackers who commit cyber crimes to harm the organization, and they often have targets of the specific data categories that they are looking for. So those categories of information include personally identifiable information. This can range anywhere from social security numbers to phone numbers, names, addresses, or just healthcare information. Trade secrets and intellectual property. This is more specific to organizations, and it includes anything such as patent information, coding dialogue, or chemical formulas, just anything central to an organization's success. And then the last is private financial information, and this includes any data on debit or credit card information, bank account numbers, or just any tax information on an organization or individual. So for our presentation, we wanted to focus on 4 main types of breaches, and those are ransomware, malware, phishing, and denial of service. So starting with ransomware, this is an attack that gains access to vital data or information, and then it locks the data from being accessible to the owner, and they demand some form of ransom in return. And this type of attack commonly targets businesses who can afford to pay the ransom, or in which it's vital that they do, either through money or some other form. And then the non-payment of this type of attack typically results in data and information being deleted. So some common forms of ransomware, leakware. This is an attack that threatens to release information if the ransom is not provided. And then crypto ransomware. This is an attack in which hackers will steal information or data, encrypt it, and then demand a ransom. And once that's provided, they will decrypt the file. Malware is the second category, and this is a malicious software that is designed to harm files. And it typically masquerades itself as some type of warning, and it convinces or intimidates users to click on a link that in turn downloads some harmful software. There's some examples of malware. The most common are viruses. These are technological bugs that attach themselves to data in order to purposely harm what's in the files. And then spyware, this is an attack that monitors computer activities such as mouse movement or screen captures or any keyboard activity as well. Then this is about phishing. So this is a social engineering attack that typically mimics some sort of trusted entity or trusted source that the victim is familiar with. The common targets of this attack are banking information or personal information. And these messages can come from emails, pop-up browsers and websites, text messages, or phone calls. So as I mentioned, phishing, this is phishing by the phone. So hackers will typically illegally gather some type of confidential information before the call, and then they will frame some storyline that seems credible to the victim. And then email phishing, this is the most common type of phishing, and it just involves emails that look like they're from a trusted source, and they contain links also to harmful software. And then our last category is denial of service. This is an attack that blocks access to websites either internally or externally. And this disrupts several of an organization's sites, which leads to the degrade of their performance over time. So denial of service attack typically comes from one hacker or one source attacking a victim, where a DDoS is a distributed denial of service, and that comes from multiple sources attacking the same victim. So some examples of these: volumetric attacks. This is where hackers will flood a service or a company's network sites with massive amounts of traffic in order to render the site unavailable or inaccessible to both parties of the system. And then protocol attacks. These exploit the vulnerabilities within a network's communication rules, targeting more confidential information once they're able to get through those vulnerabilities.
So I'm going to go over some more current conditions surrounding data breaches. So for a couple notable examples was Equifax in 2017. They had a vulnerability in a web application they used called Apache Struts. And this data breach was notable because the breach occurred in March of that year, and they didn't discover it until July. And consumers weren't notified until September. So there was an outrage about that because over 147 million this personal data was exposed and they weren't notified. And their social security numbers and credit cards were included in those things. So Equifax faced severe consequences. They had a $700 million settlement and their CEO resigned. And they faced a lot of reputational damage because they were no longer trusted by the public. So a key takeaway from this data breach is that when it happens, companies need to act quickly and they need to be transparent with their customers. Another notable example is what happened with Marriott International in 2018. In 2016, they acquired Starwood Hotels, which include Westin and Sheraton hotels for a more familiar name. But there had been a data breach going on since 2014 that they didn't discover until 2018. So this was caused by a vulnerable reservation system when customers were booking rooms. So over 500 million customers have their names, birthdays, addresses, and contact information leaked. And this made them vulnerable to identity theft, fraud, and phishing scams. So a big takeaway with this data breach is it highlighted the risks to cybersecurity when there's a merger acquisition of companies. And so some consequences for individuals. People can face financial loss when there's unauthorized transactions made on their accounts if their bank account information is stolen or credit card information is stolen. They can have their identity stolen, and happens when the criminal impersonates a person, and they can open up bank accounts and credit cards in the victim's name or take out loans. Another big issue with identity theft is the criminal can commit crimes under the person they stole the identity from, and that person, it can be really hard to clear their name even though they didn't commit the crime. And there's overall just like a loss of privacy, and it can affect their personal lives and relationships. So data breaches are also really bad for companies. When it happens, they have to pay for investigation and remediation expenses, fines, and legal fees. Oftentimes, they have to pay for fraud protection for the people that are affected, and they overall have a loss of revenue because they're no longer trusted. People don't want to do business with them because people lose confidence in the company's ability to secure their information. There can also be a loss of intellectual property, and when trade secrets are stolen, it takes away a company's competitive edge and give the competitors an unfair advantage. And lastly, it can disrupt their day-to-day operations. It can cause website downtime, slow response times, and mess with deliveries.
Next, we're going to talk about some mitigation measures or some ways to try to prevent a data breach from occurring. So here's some preventative measures. Typically, companies and corporations will use a layered security measure, so multiple at the same time. This could just be like firewalls, antivirus software, security awareness training for the employees. Here are three that I wanted to talk about today. First one is data encryption. So it's essentially making data unreadable without the proper keys to access it. This ensures data integrity and then creates trust between the organizations and their clients because they're protecting their information. Next would be multi-factor authentication. So this just is a security measure that has multiple verification factors. So it makes it a lot harder for unauthorized users to access the information. Additionally, it's important to have specific access controls for the employees and the users so that they don't have access to information they're not using for their daily job functions, because if they did, it would have a lot more of an impact if there was a data breach. And then lastly, it was the regular audits, security audits and updates. This not only helps identify potential weaknesses in their security, but also makes sure they're up to date on the industry's current best practices, as well as the current laws and regulations surrounding the security measures. So here are some best practices, just in general, whether or not this is to help prevent a data breach from happening, but also recovery processes if it does happen. So the first one is an incident response plan. So this is developing a plan in case there is a data breach and what actions need to be taken. So for example, that would just be containment, eradication, and recovery phases. So just making sure that they have a quick response would help reduce costs and hopefully reduce damages as well. Next is secure hiring and termination procedures. So Stanford University found that 60% of data breaches in 2023 was due to internal actors accessing the information. So when you're hiring, you just make sure that they are monitored closely, and then as well as whenever the offboarding process, you want to make sure that they don't have access to information that they could potentially take with them after they leave the company. Next is endpoint security solutions. So this is just securing endpoints or devices such as desktops, laptops, and mobile devices that could could be exploited. This is especially useful in remote work whenever people are working at home, their information it's less secure. So this prevents unauthorized data transfers as well as the text malware and other common threats. And then last would just be data breach monitoring tools that they can implement. And here are some examples of those that you can choose from. Falcon Insight and UpGuard Breach Site, they both just monitor and block data breaches from occurring. Praise Kill Switch manages an organization's risk levels of data breach due to stolen or lost devices. And then let's just do Spy Cloud. They have insight into data from the dark web after a cyber criminal has stolen it. So these all you can just implement to help detect and monitor if there was a data breach that has occurred.
So now we're gonna go into some future considerations about data breaches and how they will impact businesses and individuals. So the biggest thing I wanted to talk about here is how data breaches will be impacted and how they'll be carried out through the use of AI, because AI is becoming a much more relevant part of everyday life now. So AI requires a lot more data in order to operate. And with this increased data, there is also going to be an increase in the risk for data breaches. And that kind of leads into one of the most common types of data breaches, or one of the most common types of attacks on AI systems specifically are adversarial attacks. So adversarial attacks occur when the attacker makes a subtle or unnoticeable change to the AI model's input data. So for example, if an attacker changes like a very small part of an image or a speech signal, the AI model will misinterpret it and it'll actually fool the AI system and allow that attacker to enter the system when it's not actually them. This also leads to an increased risk of data leakage. So data leakage is a little bit different from data breaches, but they are unintentional leaks of personal or sensitive confidential information that are accidentally released by AI systems. So this is, if you think about like if an AI system is analyzing medical records or financial transactions, you definitely don't want that kind of data out there for everyone to see. And if it gets leaked, it's out there for hackers to potentially exploit. And just some other future implications that I was researching. So the fines that are associated to the mismanagement of data subjects is predicted to exceed $1 billion by 2026. And this is predicted by Gartner, which is an IT services and advisory company. So they claimed that these fines are basically showing that companies are not doing a good job at protecting their customers' private information and data. So these customers are taking legal action against companies and demanding that there be changes to the laws and how the companies are using their data. And if it keeps getting breached, that's obviously not a good thing. And this number kind of shows that it's going to continue to be an issue. And then obviously human error will always remain a major vulnerability. We talked a little bit about phishing and other kinds of social engineering tactics that are aimed to steal information. We all have a degree of human error. So it's going to be hard for, in the future, data breaches will continue to happen because of that level of human error. And finally, as technology advances, so do the cyber attackers. So as technology becomes more sophisticated with things like AI, the cyber attackers also find more sophisticated ways to breach sensitive data. So an example of this is that instead of targeting like bigger corporations who have invested a lot in cybersecurity, there's kind of a shift towards targeting vendors of these large companies, because if they haven't invested as much into cybersecurity, then it's easier for them to enter the system. So if they can enter the system, they can access all the vendors' customers and get that kind of personal information. And just to wrap everything up, we've learned about a lot of different types of data breaches, and they're all aimed at
either stealing, viewing, or sharing that personal or sensitive information that we don't want out there. And then, as I talked about, data breaches will continue to be an issue into the future. They're not going to go away, which is why it's important that we take preventative measures, that companies and individuals take preventative measures in order to ensure that they're not a victim of a data breach. Thank you.
So one of your early slides was about how breaches happen. I believe you said errors, insiders, and hackers. Do you know roughly about what is the frequency of occurrence between those three types of attack or three types of breaches?
I believe it would most likely be the cyber criminalists, and then it would move into innocent mistakes, and then the malicious insiders.
There's obviously some discussion on AI, which I think is a very interesting topic. I was thinking about AI from a different perspective. Is there a possibility that we could start seeing more phishing and social engineering attacks that are AI driven?
I could definitely see that becoming an issue just because if a person can just ask an AI bot or something to do that work for them, it's easier to target more people and manipulate more people, especially through things like emails and just other phishing tactics like that.
Now, one of the themes that your presentation touched on one of the themes that we've talked about this semester. Obviously, prevention is really, really important with respect to data breach. It's really, really hard to have detective and corrective mechanisms after the fact, and even if that's the case, there's already a cost loss. Is there a legitimate argument for a cost-benefit trade-off when it comes to prevention tools? And if so, how do you make that argument to like an executive who can't see the benefit of data prevention or data breach prevention?
Just with the rise of data breaches as technology also grows, I see what you're saying, that like the cost of implementing these solutions would sometimes be more than the cost of the data breach. But just with those specific cases that they saw, is like what Anna was talking about, it can be really significant. And so just explaining that like it would have a major impact if they didn't take a decent amount of preventative measures, and I think they would be able to.
And another thing that you pointed out, and I this may be an unfair question, but I'm going to ask it anyway. So you mentioned that human error is likely going to be one of the big drivers for data breaches in the future, which I agree with, because technology is only becoming more and more complex over time. And so we're asking the same people to do more complex tasks, and that's going to continue to become problematic. How do we address that problem, that technology becomes more complex, but we as individuals don't get more intelligent over time?
Maybe a solution is just like more education about it, because I know like a lot of older people have issues with like clicking suspicious emails, like being victims of phishing and things like that. So maybe like since we have all this technology at our fingertips as younger individuals, maybe this like the evolution of like a new generation could like help prevent it. But overall, probably just more education could like help that, and learning how to like recognize something that's phishing or trying to get your personal information.
Yeah. Questions? All right, good job. All right, some very good presentations to start off. Those of you who are presenting later in the week, I will take some notes on what was done here, because I thought both presentations are very good, and those are some good key ones. Got a lot to live up to for the next few presentations. So see you all on Wednesday.